This is the third video about structures. In this one, we're going to take a look at combining structures with functions. As it turns out, there are several ways that structures and functions can work together. First, we can send a structure, or just part of a structure, to a function as a value parameter. Recall, that means we're sending a copy of the structure to that function, and any changes we make to that copy will not affect the original structure's data. We can also send a structure to a function as a reference parameter. We'd do this if we want to change something about the structure's contents. And when I say contents, I mean we could change part or all of the structure's data located in the members. Those changes would affect the original structure because the parameter would be an alias for that original structure. Finally, as with any other data type, a function can return a structure. Let's take a look at how all that works. We're still working with our car info structure type. I have a prototype for a function to calculate how many miles a vehicle is averaged per year. Please notice that the getMilesPerYear function is expecting two integers. Those integers will represent the car's year and its mileage. I've also declared a car info variable named car1, and I've initialized it as shown on line 21. On line 24, I'm calling the getMilesPerYear function to get a value for the miles per year variable. Look at the arguments that I'm sending to the function. Car1's year member and Car1's mileage member. I don't have to send the entire structure. I just need to send those two values from the Car1 structure. Then on line 26, I'm going to print out the contents of the miles per year variable. To write the getMilesPerYear function, first I need to figure out how many years the vehicle has been driven. So on line 33, I subtract the vehicle's year from the current year, which was defined as a constant. On line 35, I get the average number of miles per year and then return that value. Running the program, I get to see that this 1967 vehicle has averaged a little over 4,800 miles per year. But there will be times that I do want to send the entire structure to a function. Line 23 is showing you just such a situation. I want to print out the contents of the car1 variable. Look at the prototype on line 17. I'm sending a car info structure as a value parameter. In other words, I'm sending a copy of the car1 structure. In the function itself, I'll print out the make and model, then the year and mileage, and finally the value shown with 2 decimal places. Here's what the output looks like. Anytime that I want a function to change the contents of a structure, I have to send the structure as a reference parameter. Here's how that situation could come up. I want to send the car1 variable to a function that will get values for the structure's members. So on line 23, I'll call a function named getCarData, and I'll send it car1 as an argument. Then I'll come up to line 18 and declare the prototype. One really important thing to notice is that the parameter for this function will be a reference parameter. As shown in the prototype and in the function heading on line 30, the function is void. How come? Well, I'm not returning anything because I'm modifying the structure through its reference parameter. Inside the function, I'll ask for the make and model of the vehicle. I'll follow that by asking for the year and the mileage. Then I'll ask for the vehicle's value. Just to repeat, when the user enters the values for the car info structure parameter, they're actually changing the contents of the car1 variable back in the main function. When I try to run the program, I get the error message that we've all seen so many times. When you see this, make sure that you never click the Yes button. Always choose No. When I do that, I'm seeing this error, and it tells me the linker can't find the getCarData function that I called on line 23. Looking at my code, I see I named the function getCarInfo on line 30 instead of getCarData. That's why the linker couldn't find the function. So I'll fix that mistake and try running my program again. This time it runs and the user enters her data. Right below that is the output from the printCarData function that I called back on line 24. In the last example, I sent the car1 variable to a function as a reference parameter. I did that to get the values for its members. Here's another way of accomplishing the same thing. On line 18, I'm changing the prototype to indicate that the getCarData function is going to return a structure of type CarInfo. Then I indicate that it won't receive any parameters. I also have to modify line 25 to indicate that the getCarData function will return a value that will be stored into the car1 structure. Now this is real similar to the way you've gotten values for variables before. The only difference is this time it's a structure. On line 32, I'll modify the function heading to match the prototype. This function is promising to return a structure of CarInfo type. Where's that structure going to come from? The answer is I have to define a local variable of type CarInfo, and that's going to store the user's values. Then I can return the structure in that local variable. If you look at line 43, that's exactly what I'm doing. Now I run the program and let the user enter her values and then print the results. To the user, she can see no difference between this version of the program and the last example. The last example illustrated using a structure as a reference parameter. This one's illustrating returning a structure from a function. When to use each of these depends on the specs of the program. As you saw in the reading, there might be times when you want to send a structure as a reference parameter even though you don't want to change its values. Here's when that might occur. Let's pretend that our CarInfo structure has not just those 5 members that we've been working with. Instead, it has extra members, starting on line 15, and then has dozens and dozens more than I'm not even showing here. If we had a variable that contains all of that information, we might not want to send that as a value parameter. That is, maybe we don't want to make a copy of all that information because it would take up a whole lot of room. The solution? Well, that's to send the structure variable as a reference parameter. In that case, only its address, that is, a reference, is being sent to the function. That address takes up almost no room at all. But then that creates a problem. Now the function might accidentally change the original variable's data. The solution is pretty simple. Make the parameter a constant CarInfo reference. Here's what that looks like. First, I change the prototype, then do the same thing in the function heading, and the result? Only a small piece of data, that is the address, is being sent to the function as a reference. But if the function tries to change the contents of the structure, the compiler is not going to let it. Here's the error message I got when I tried to change the reference parameter's data on line 61. It's telling me that the parameter is a constant. Step back for just a moment and think about how I've been using structures with functions here. Sure, I know the structure has multiple members, but when it comes to functions, is a structure that much different from the simple data types?